The School of Systems and Enterprises is very focused on the design and management of complex systems, such as defense systems, aerospace systems, software engineering, and engineering management, and so on. We are the only school in the nation that's basically dedicated for systems design and management, and also enterprise design and management. And this is actually a very unique opportunity, because in other places it will be a program, small program, or at best a department. The fact that we have a school here enables us to have the infrastructure for the students to be able to really have easy access to the industry, have easy access to work with other schools within Stevens and also other schools outside. What distinguishes the design of complex systems is basically its ability to be able to handle all the complicated surrounding environments, and in addition to the difficulty in the design of all the components that come together. So the ability to be able to design a holistic system that basically will function much better than, of course, if you're designing just component by component.
So complex systems are a really difficult topic to study because of their long life cycle, their large scale. Most engineers in practice may only interact with one or two of them in their whole careers. So introducing students to complex systems is a big challenge. One of the things that I've been advancing both in my classes that I teach and in my research is the use of interactive simulations to help give people the opportunity to interact with complex systems on a shorter time scale of 1 to 2 hours, rather than having to spend an entire career on them.
The SSE research is distinguished with its interdisciplinary nature studies to address some of the most challenging socio-technical problems across multiple critical domains. So our students can work with the faculties on some of the most hands-on experience so that they can immediately take it into their workplace.
So it's actually vitally important to expose students and let them practice in a real-life software development setting. In order to do that, we create really hands-on projects that students will work in teams, and they're not just learning the concepts and the fundamentals in software engineering. They actually practice in real settings we create that for them.
The Systems Engineering Research Center is a university-affiliated research center. A UARC, a university-affiliated research center, is established by the Department of Defense in areas of strategic importance to the department and to national security.
So the system engineering community is addressing complexity through a number of different factors. One is really in human capital development. So systems thinking and understanding data and data analytic skills are a big part of it. We're addressing the system of systems complexity through new tools like network analysis, machine learning. Those kind of technologies will do that in the long term. The transformation over time to a more interconnected digital view of what engineering is will help connect all those different disciplines together.
What we are trying to do is take the best of what's going on in the commercial world and things that are being invented in the universities and help the Defense Department incorporate these in how it does its system engineering of systems, its evolution of systems, its determination of what systems to replace or modify or that sort of thing.
Trusted systems, if you consider what trust means, is essentially that you believe that a system is going to do the right thing. Right being how it was designed, what are the requirements. Trust tends to traditionally take a view of security. So the newer systems that the government has have increasing elements of cyber in the systems for computational control. So systems are now vulnerable to cyber attack in ways that they were never vulnerable before. And that's a big concern. Model-based assurance, relating back to we need a model to say how a system is going to perform. Are we certain it's going to perform the way we want it to? Trust is the same thing. We need to be able to trust that our model-based process is going to produce a system whose behaviors and performance we trust.
We are contributing to the evolution of systems engineering as a discipline, not just through our research, but also through the contributions we are making to systems engineering education.
The School of Systems and Enterprises at Stevens Institute of Technology allows the students to work on state-of-the-art problems and tackle real-world applications.